Welcome to Effective AI Coding. This course is about one thing: building real software using AI tools, specifically Cursor, from an initial raw idea all the way through a live deployed application that you can hand off to your team. We're going to cover 7 modules. 7 modules. Each module has a worksheet. The worksheets are not optional reading, they are the work. Everything you write in one worksheet becomes a direct input that drives your AI to the next step. So these are every worksheet is input for the next stage. By the end of this course, you'll have a repeatable, structured process for scoping, building, deploying, and handing off any software project with AI assistance. You won't be guessing at prompts. You won't be going in circles with AI. You'll have a system. So let's look at what that system looks like. Module 1 is planning. This is where we make every decision before we touch Cursor. Architecture, tech stack, feature scope, roles, and UX rules. Module 2 is goal prototyping. This is an important step. We take everything from Module 1 and turn it into a seed file. We use that seed file to generate a working HTML wireframe. This is using fake data. We use that wireframe to get stakeholders' approval on features and to mold the general direction of the project before any real code is written. Module 3 is feature changes. Based on what we learned from the prototype review, we log every change, we resolve any open design questions with AI assistance, and we produce a final seed file. So we had a first seed file, and now we have a final seed file. Module 4 is project creation. This is the build. We hand the final seed file to Cursor, and it generates the application. This is the build phase. We review every file and run a smoke test. Module 5 is development and startup. We provision the server, upload the code, manage secrets correctly, and get the application running live. Module 6 is testing and validation. We write a test plan from our seed file features, run every test, check edge cases, and complete a security checklist. But we also, during the testing and validation stage, we go back and fix the errors. So that's a big part of testing. It takes quite a bit of time, but we want to eliminate that going back to testing as much as possible by making these changes early in the development phase. And not only is it cheaper because it costs money to develop with AI, but it just takes a lot less time. In Module 7, the last module, is handoff and iteration. We prepare documentation, train the team, and plan the next build cycle. These 7 modules are sequential and dependent. Don't skip ahead. The output of each module is the input of the next. I hope you understand that. I guess it's the 3rd time I said that, but yes, don't skip ahead. Go in order. Do each worksheet. Feed each worksheet into AI. Module 1, planning. The subtitle here says it all. Define your project before you write a single prompt. This is where most people fail with AI coding tools. They open Cursor, type something like, build me a project management app, and then spend the next 2 hours arguing with AI about what they actually wanted. We're not going to do that. Before we write one word in Cursor, we're going to know we're going to know exactly what we're building. Who's it for? How's it architected? What technologies are used? What features are in? What features are out? Who the users? That's important. What features are out? Yeah, we'll get to that later. Who the users are, and how what features are out. This prevents AI from coding a bunch of garbage you didn't ask for. So you got to create a what's left. That's very important. That took a lot of expertise, a lot of time building AI projects before I created this list of what's out. Anyways, I digress. And how the interface should look and behave. Worksheet 1 is how we capture all that. Let's go through it section by section. All right, here we go. Module 1, learning objectives and overview. Here's what you'll do in this module. You'll write a project overview paragraph. It'll be 3 to 5 sentences that describe what the application is, who it serves, what the problem it solves. You don't want to make a backup application that doesn't solve any problems. You want to make sure that it's solving problems. And you have to define those problems that it's solving. You'll choose your cloud architecture with AI assistance. It'll help you decide what instance to use and how much space to use, and it'll help you decide all that. We'll use Cursor in plan mode, not in build mode, to work it through infrastructure decisions. You'll define your tech stack with exact versions. And I mean exact, not Python. Python 3.12 with fast API 0.110. You know, the exact versions. The AI generates better code the more specific you are. It's cheaper and it takes less time. Your lock-in scope versus deferred features. This is critical. The AI will try to be helpful by adding features you didn't ask for. This is what I was going back to earlier. The explicit out-of-scope list prevents that. You'll waste a bunch of time getting rid of stuff. You'll make one change and they'll add 3 other things into it. It's just a big mess. So you want to maintain that list too. And you'll establish roles, access rules, and UX constraints that the AI will use as guardrails throughout the build. Now, why does all this matter? Because every answer you write in this worksheet becomes part of your seed file. The seed file is a single document. It's a text document that AI treats as its source of truth for the entire project. If the seed file is vague, the application will be vague and you'll get stuff you didn't ask for. If it's specific, the application will be specific. The key principle on this slide says it plainly. Python is not enough. Write Python 3.1.2 with fast API. The AI can only build what you precisely describe. Worksheet 1 has 7 sections. Worksheet 1 has 7 sections. I've grouped them into 3 clusters here. The first cluster, section 1.1 through 1.3, covers your project and tech stack. You're writing the overview paragraph, choosing your cloud provider and compute, and specifying your exact tech stack, including database and authentication methods. If you're unsure about any of these, that's fine. We can use AI in plan mode to work through the decisions. That's exactly what it's designed for. The second cluster, sections 1.4.1-5. This is your feature scope. Sections 1.4 is what's in. Section 1.5 is what's out. Both are equally important. When you list a feature as in scope, you need to describe its behavior specifically enough so that AI can implement it without asking follow-up questions. User management is not a feature description. Admins can create, deactivate, and delete user accounts. Standard users cannot access admin feature functions. This is a feature description. The third cluster, sections 1.6 and 1.7, is your roles and UX rules. Name every role. State exactly what it can do, and list what it's restricted from. Then write 5 to 8 plain language design rules, including your brand colors. These become constraints the AI respects throughout the build. Your worksheet has example answers filled in for every section. Use them as a guide for the depth and specificity. Yeah, being specific, you know. And module 2 is goal prototyping. The subtitle, see the application before a line of code is written. I want to take a moment on this idea because it's counterintuitive. Most people want to start building immediately. The prototype feels like a delay, but here's the reality. A misunderstood requirement that you catch in a wireframe costs you nothing. The same misunderstanding caught during build cost hours. Caught after deployment, it costs days and erodes trust. We're going to use our seed file, which we just created in Module 1, to generate an interactive HTML prototype. We're going to review it against a checklist, show it to at least one other person, and document everything that needs to change before a single line of real application code is written. In this module, you'll do 5 things. First, you'll compile everything from Worksheet 1 into a seed file. To do this, attach your completed Worksheet 1 to Cursor and ask it to create a file called seedfile.txt. The seed file must contain 8 specific elements: the project overview, architecture, auth rules, feature description, data model, UI layout, deployment constraints, and the deferred features list. The worksheet will walk you through checking off each one. Second, you'll generate the wireframe. The prompt is simple, and this is the first time you'll see this. You'll see the wireframe is a cool. I enjoyed this part of it because I get to see it before I build it. Tell Cursor to generate an HTML wireframe using fake data. That's important. You got to make sure it's using fake data to show all functionality described in the seed file, not real data. This is a visual prototype only. Module 3, feature changes. This is the last stop before the build begins. You've seen the prototype, you've collected feedback, now we formalize what changes, make any remaining design decisions with AI assistance, and update the seed file to reflect everything. The output of this module is final seed file.txt, the document that Cursor will use to generate the actual application. What I want to stress, changes made here are free. Changes made after the AI generates your application requires AI to revisit generated code, which introduces regressions and inconsistencies. Get it right here. In Module 3, you'll do 5 things. You'll log all changes from the prototype review. Every change gets classified as one of 3 types. New means you're adding a feature that wasn't in the original scope. Change means you're modifying the behavior of an existing feature. Remove means you're explicitly cutting something. You'll use AI in plan mode to resolve any open design questions, not build mode, plan mode. For each question, the AI will offer you options. You record those options, make a decision, and document your rationale. This creates an audit trail of why the application works the way it does. You'll update the seed file to reflect every change, and then you'll verify it. The verification step in section 3.3 asks you to reread the entire seed file from start to finish and confirm that every change is reflected. No contradictions exist. Every feature has sufficient detail and the document reads coherently. Do not skip the verification stage. It takes 10 minutes and it prevents hours of rework. The output of this module is final seed file.txt placed in the step 4 folder, ready for the build. Module 4, project creation, from seed file to running application. This is the module people are most excited about and the one where the most mistakes happen. The AI is going to write a lot of code very quickly. Your job is not to watch it happen and assume it's correct. Your job is to understand what was generated, run the smoke test, and track every bug systematically. Let's look at how we do this well. In Module 4, the first thing you'll do is attach final seed file.txt and a run file around the AI questions in plan mode. Ask if the AI has any clarifying questions about the project before you switch to build mode. This surfaces ambiguities and would otherwise become bugs. Then you switch to build mode and issue a build prompt. Ask Cursor to generate all files required to run the application and also to generate a step-by-step deployment guide for the target environment. Do not abbreviate any file. You want a complete implementation. Once the code is generated, you'll review every file it created. This sounds tedious, but it's essential, guys. You can ask the AI what each file does. Build a table in your worksheet. File path in one column, what it does in the other. This table becomes your reference for any future modification. Then you run the smoke test. 5 checks. First, does the project start without syntax errors? Second, does the main page load in a browser? Third, does login and authentication work? Fourth, does basic navigation between pages work? Fifth, does at least one core feature work end to end? Just one core feature end to end. We'll explain that why in a minute. If any of these 5 fail, stop. Do not proceed to the deployment. Fix the failure. Rerun the check and only move when all 5 pass. Module 5, deployment and setup. Ship it. Get the application running in production. This is the challenging part. It requires a lot of engineering skills because you're basically taking it from a local file on your computer and shipping it to its production wherever it's going, AWS, GCP, wherever. Everything we've done so far has been a preparation. This module is where the application goes live. We provision the server, upload the code, configure the environment, and verify the application is running correctly on the correct port with the correct configuration. There's also a critical topic in this module that many developers treat as an afterthought, secrets management. We're going to go do it right from the start because we're security. In Module 5, you'll provision your server to match the architecture you specified in Module 1. The operating system, instance type, network rules, these should all be matching your decisions from Worksheet 1. If they don't, stop and reconcile that before proceeding. You'll upload the application code and install all runtime dependencies. Pip install, npm install, and whatever your stack requires. Then, and this is the part I want you to pay close attention to, you'll manage secrets correctly. A secret is any credential, API key, or sensitive configuration value that your application needs to function. Database connection strings, JWT secrets, third-party API keys, all of these are secrets. The rule is simple. Secrets never go in source code. They never go in version control. Never. Not even in a private repository. Secrets go in environment files, environment variables, restricted file permissions, 600 and 640. Section 5.2 in your worksheet has a table where you can list every secret your application needs, where it's stored, and how it is generated. Fill in every role. After setup, you'll verify startup. The service starts without errors. It responds on the expected port. Logs are being written, and database was initialized, and default admin accounts exist and can log in. Then complete the initial configuration in section 5.4. Change the default admin password. Configure your external service credentials. Create team user accounts and verify that everyone can log in. Module 6, testing and validation. Prove the application does what you said it would. The application is now live. Now we can verify that it actually works, not just in the happy path, but under real conditions, bad input, unauthorized access attempts, service failures, concurrent users, downtime, everything. Testing is not optional. The application that passes the smoke test may still fail on edge cases. An application that passes functional tests may still have security vulnerabilities. We'll go through it all systematically. In Module 6, you'll convert every feature in your seed file to a test case. The format is win action, expect result. This forces you to think about each feature as a behavior, not a concept. For example, the slide shows when an admin deactivates a user account, expect the user cannot log in and sees a clear error message. That's a testable statement. You can run it, observe the result, and record pass or fail. You run every test case in your test plan and record the results in section 6.2. For anything that fails, document what you saw and what the AI's fix was. It's really important to be thorough here. Go through the whole application, not just piece by piece, not just function by function, but go through the whole application and make changes at one time. But at piece at a time when you're entering into cursor. Section 6.3 covers edge cases. Does bad input produce a 500 error, or is that handled gracefully? Does an unauthorized user attempt to access restricted route get blocked, or does the UI just hide the button while the backend stays open? Does the application handle an external service being unavailable, or does it crash silently? Section 6.4 is a security checklist. Credentials encrypted at rest. No sensitive data in logs. Session cookies are only HTTP only and secure. Role-based access is enforced on the back end, not just hidden in the UI. Secret file permissions are restrictive. Default credentials have been changed. I want to call out the last security check on role enforcement specifically. This is very common for AI-generated applications to implement role restrictions on the front end, hiding buttons or routes from certain users while leaving the underlying API endpoints completely unprotected. Test this explicitly. Make an authenticated request to a restricted endpoint as a lower privileged user and confirm you get a file 403. Module 7, Handoff and Iteration. Transfer ownership to the plan and what comes next. Transfer ownership and plan what comes next. The application works. The tests pass. Now we make sure that people who own and operate the application actually can without you in the room. This module is about two things: making your work durable enough to document through documentation and knowledge transfer, and setting up the next build cycle as a structured backlog in retrospect. You have to sell your dang program, man. You have to get buy-in for your program. You have to make sure people know it. They know how to use it. You can't just be the only one that knows how to use it. You have to get other buy-in. You have to sell it. You have to sell it. You have to be a salesman. It's not good enough just to have great work. You have to sell your work. That's true in anything you do. In Module 7, you'll assemble the full documentation package. That's 5 documents: the project requirements and final seed file, the setup and deployment guide, the project steps overview, the architecture decisions about document, and the troubleshooting guide. All of these must be updated to reflect the final state of code, not what you plan to build, what you actually built. You'll demonstrate the application to the team, and you'll walk through the admin functions with them. You'll explain backup and recovery procedures and how to update the application and how to rotate secrets and credentials. You'll answer all their questions. Don't close the knowledge transfer until every question has an answer. Section 7.3 is the Iteration 2 backlog. Collect feedback from users and stakeholders. Collect feedback from users and stakeholders. Collect feedback from users and stakeholders. To be able to get some people's buy-ins, you have to do what they ask. It may not make much sense sometimes, but it helps them, and there's other people like them. So just do it. If you can do it, just do it. Assign to get buy-in. Assign each item has a priority, high, medium, and low, and record where each item came from. The backlog becomes a seed for worksheet 1 for your next project cycle. Section 7.4 is the retrospective. I want to be direct about this. The retrospective is a section most people skip, and it's a section that produces the most improvement over time. Answer 3 questions honestly. What worked well in this process? What was frustrating or inefficient? What would you do differently next time? And this is how I created this course over many iterations of retrospects. Also record how much time the planning phase saved you during the build phase. If you can put a number on it, even roughly, you'll understand basically what the worksheets are worth completing. Why the worksheets are worth completing. You now have everything you need. 7 modules, 7 worksheets, a process that takes you from idea through planning, prototyping, building, deploying, and testing to a live application in the hands of a team. The 3 words on this slide are the sequence: plan it, build it, ship it, and get buy-in. And shipping, get real software in front of real users, is the only thing that actually matters. Complete your worksheets in order. Each one feeds the next. Resist the temptation to skip ahead or treat any section as optional. The structure is the point. Good luck. Good luck. If you take nothing else from this course, take this. The AI is only as good as the instructions you give it. The course is a system for giving better instructions every time. Thank you, and go build something.